work. So this. Okay, so Josh, I just turned on the recorder. I'm going to make you God, and let's just let this thing run all the way through lab till about 10 o'clock and see if it actually works.
Sounds good.
The experiment is I will disconnect at 8:50, and the recorder should still be run if you are the so you are now host. So you should have host privileges. And if it drops you at 8:50, I'll restart from my office.
Okay. I just checked to see if I could share screen and everything's working. So sounds good. All
right, cool. So there was an ulterior motive for all that silliness. This Friday, I have to be at the dentist office because they're going to put it on. I won't be here Friday of this week. That's not a usual thing. If I get it together, I will attempt to pre-record the lecture, but your Friday lab will still happen. Josh is more than capable of doing the Friday lecture in lab, so we just want to check the electronics. All right, so the next thing on my list is to do some semblance of taking roll. It's going to be a little harder because usually if I do it by hand, I want to do it on a piece of paper. And Josh, I'm just going to turn off my video because actually, let me see if I can share my screen. I can't.
That's fine. I'm just here listening.
You'll be able to hear what's going on. All right, so I want to take roll. I don't actually have the roll on this computer, but I should be able to get to it because I quickly dropped it into somewhere else. And this will actually help us introduce. Okay, so for this class, everything that I do in this class, relevant to you all, is stored on a server with that peculiar IP number. Don't worry, you don't have to remember it because it's in the Blackboard. Blackboard has the link. If you end up going through this route, you would go through these navigation things, and I want to actually get to my deployment server because I'm looking for a file. Now you guys won't be logging onto my server unless I screw up at some point in the next 4 months and give you the password. Oh, it's running really slow when all this. Nothing's easy today. Okay, so everybody's here today. We will bypass that, I think. I don't know if that's Texas Tech Network issues or Amazon. So we'll go to introducing to Blackboard and see if I can't crash that also. So to get to Blackboard, looks like I've been there already, so it should. It's probably actually Texas Tech Network. Just realized there's probably 2,000 classes that are logging into Blackboard right now. We'll make it 2001. That is not your class. You guys are this semester. So you're all in, this is section 1. And there's another section, section 13. It looks the same. You should not be able to log into the wrong section. But if you do log in and somehow it lets you and things look funny, it's possible that you've logged into the wrong section. Just check that you're in section 1. So in Blackboard, your homepage will look something like that. So Blackboard, as you know, is an electronic black hole, and that's what it looks like when you're in a black hole trying to get out. um, to the rest of the universe. There's a welcome thing and there's nothing there, so don't bother looking at the welcome. There is a syllabus link. We'll take that in a second. And there are the instructor notes links. These are the notes that I use in the classroom. There's also a folder called laboratory, folder called homework, folder called videos. The only thing in videos that's of any consequence for you all this week is a YouTube video on installing Anaconda, which is the scripting environment that we use in this class. So, and Anaconda is not like other stuff that you install. I mean, you go to the internet, you download it, you press the installer, everything's pretty and it works, and it asks you if you want to be allowed to sew your mouth to the back end of the creature in front of you, just like in the South Park episode. So all that is normal. It's just that it is free software in terms of the money that's expended, and as such, not everything works as expected, which is unfortunate, but that's just the way it is. And in a way, it's something you need to get used to for the rest of your career anyway. In the laboratory one, for instance, there are 2 lab exercises here, and this list will grow. It'll grow somewhere up around 33 or 34. So there's a bunch of labs. Each one of them has a relatively small point value. Each thing is usually worth 3 points. So if you miss one, that's not a big deal. 1 out of 33 is kind of not a big deal. If you miss 9 or 10, you're now starting to toss away what are essentially easy to obtain points. We'll just click on Lab 0, for instance. And if you actually select the object, it has a due date. So this, the Lab 0, which is for today, is due a week from today. Tells you how many points it's worth. It'll almost always be 3. It's just easier to divide everything by 3 because it's an odd number. That pun will have some significance in a few weeks. And when you have your submission complete, you want to, oh, I made a mistake there. You're going to want to upload Python notebook, which you'll learn about what that is today, and PDF rendering of it. Don't attempt to upload an HTML rendering of it. Blackboard server won't let you. It'll say, oh, HTML, you must be inserting malicious code. You will be reported. I think I tell you will be reported. Nobody looks at the logs, so you really won't be reported. Lab 1, for instance, is due Friday the 21st, and so on. Similarly, the homework category is the same setup, only the naming system is slightly changed. So ES0 next Wednesday. Anybody want to guess when ES1 is due? Friday a week from this Friday. And you are correct. 10 points for Gryffindor. That's probably not fun of you all, but it makes me laugh. So if I'm laughing like a hyena, you know that things are going well. The link to the syllabus is here. And you notice there was a notation, but we'll get back to that in a second. So here's the syllabus. Currently, as of right this instant in time, you see if I don't have the lecture sections correct yet. And looks like the dates are at least inserted. So you'll see some of these like 33333333333. That's obviously something called a placeholder, and it's just used to hold the place. That's where that lesson's going to go, and the dates will be checked. And then there's the scary stuff in red. We'll get to that in a second. This scary stuff in red right here, again, is placeholding. It's nothing to worry about today. But you'll be scared soon enough, don't worry. Okay, good. This is the correct assessment weighting scheme. So there are 4 exams. They roughly occur every 9th or 10th class meeting. So first exam 1 is 3 weeks and a couple days from now. That was by collective decision to have more exams with fewer content per exams, because that's easier for us to grade. It is by far easier for you all to only have to do small pieces. But don't worry, it wasn't altruism. It was easy for us to grade the guided decision. There are lab notebooks and homeworks, so you've seen at least how to get to those. Those are collectively 30% of the overall grade. Looks like we have quizzes assigned at 15%. 15, 30, 60, 40. Good. At least my arithmetic is working. Quizzes are administered on Blackboard, and we'll get to that when we get to the first one. We won't have one this week. That's grossly unfair. And then there is a final project, which you can think of it as an extended homework assignment, and that's done in groups of 3 or 5. We'll talk about that when we get closer to the time to get that started. So before I proceed forward, are there any burning questions right now? Good, awkward silence. I shall continue. And then by far the important part are the instructor names. Okay, cool. My picture finally loaded. So the notes that I use for these presentations are in here in 1330 course notes, and it has some intro stuff. The important thing here is I'm your instructor. This is our resource. If you have pals in other classes, in other sections, they may or may not be using this resource. If they're not using it, tell them be sure that you're using your own stuff that your instructor expects. Otherwise, that letter at the end, you may not get the vowel chasing after. Anyone ever wondered, it's awful convenient that there's only one vowel and 4 consonants available in the letter system. I guess that's not even reflective of the entire alphabet. The alphabet has 6 or 7 whole vowel lines. It's very interesting scripting. The alphabet has 26 characters and 6 vowels. How many consonants per vowel should be represented in the letter grade system? And along the left column are essentially the lessons as they're presented in that syllabus. So today is lesson 0. The obvious question: why are you counting 0? That will be explained in lab today. That's what's the most complicated thing we can do to the general public? So let's start counting at 0. No, that ought to screw them up. And they were successful. And then 1 data science helps, 2 expressions, 3, and so on. You will see in some of these strange numbering when you see a 4, 4.1, and 5. Anybody want to speculate a guess why that occurred? I'll tell you if you can't speculate. Someone's got to be able to guess. You put a whole bunch of effort in numbering this, right? And you realize you need to put something in between 2 numbers. Your choices are put it where it goes and then renumber everything beneath it, or just put extension to the number and slip it in there. Which do you think is a lot less work? The second one. So that's why you'll see a 4.1. So I can screw up, if I included counting 0, I can screw up 9 more times before I really have to reorder the entire list. Okay, so this environment is called a Jupyter book, and it is really just a set of web pages that are rendered to look pretty. The important thing about the web page is good. You should see a little diagram here. So these blocks, which in the Jupyter book, we're formerly calling them code blocks, those can be cut and pasted into your working Jupyter book, and that is That is the intent. It's supposed to be that way. The notes are just like footnotes. Those are notes to you as a students, more importantly to me as the instructor, because these are my lesson notes. Okay, links. Any questions before I proceed? Cool. In this Jupyter book, let's go to Introduction, which is today's lesson. This is an important heading because it's actually the only one that lets you get back to the main server. So up at the top, there's the course content server. This is more for me than for y'all. I would prefer you not to access content through this front door. I mean, there's nothing secret there, but there's stuff there that doesn't necessarily fit the course. But that's in case everything else fails. At least I have one way back to the hosting server. And if you go to the syllabus itself, which, as I just said a few minutes ago, is incomplete, down in the schedule they look like links. And sure enough, they are. So one way to access course content is through the syllabus. That is the intended or preferred way for the class. The second way for things like homeworks is at the bottom of each section that has a laboratory and homework. There is a link if you want to examine it. So it says examine laboratory 0 as the inside of a black hole again. Good thing we spent a fortune getting all this fancy hardware in here. It doesn't work. If you click on that link, it produces a web page rendering of the actual laboratory assignment. That's just so you can take a quick look at it. I don't think it would make a lot of sense to attempt to do it from here because it's not an editable document. But once you decide you're ready to edit it, you can actually go to the Python notebook. Now you notice I clicked on that, and all this gibberish showed up here. That's actually the notebook source code. If I want to download it, clicking on it is not the route to go. How do you download stuff on your computer that's not on a paid for dirty picture site? Well, if you don't remember, you can read here. It says right click and save. So you would, oh, I can't right click on a laptop because I can't make that. Control option. Oh, yes, it is. So if you choose save link, and it will put it in my downloads folder. Okay, so now I've downloaded a copy to my computer of the Python notebook. We'll go take a look at that really quickly. Am I good on time? So if I go to my downloads folder, wherever it is, there you go, downloads. And it was lab0-0. I'll open it with a text editor so you can see what's inside a Python notebook. It's the same gibberish that was rendering before. That's not very useful, right? I mean, you all can generate gibberish without having to take a 1 semester long class in gibberish generation. But if we have the proper software to interpret that that mess, we would use that. Hopefully I have it installed on this computer. So I have already installed Anaconda on this. So this is obviously what kind of computer? It's a Macintosh. You can tell because there's an Apple on the back of the thing. And more importantly, so detected that with my mouse and asked me if I want to upgrade. But it does that from time to time. So in this Navigator instance, I've just done a default Anaconda install for Macintosh. Look and feel for a Windows machine. have not bought it, I would argue that probably for your time here at Texas Tech, you're better off getting one of those type machines. Your life will be easier as far as class stuff is concerned. So the two environments that class are Jupyter Lab and Jupyter. I personally prefer the Jupyter Lab environment because I think the file system representation just makes more sense to me. It looks exactly like what my server stuff looks like. So I'll choose that. But you can also use Jupyter Notebook. It pretty much works the same way. So you press the launch command, and I've got the sound suppressed because otherwise everything shakes and it rumbles and this rocket goes up and spends 8 minutes in the sky and then comes bouncing back down. So now you look at the top, it says localhost :8888. That's a localhost is the name of the server that this web page just went to. It happens to physically reside on this machine. If you've never set up a web server on your own machine, don't sweat it. It does it for you. And then 8888 is just a port number off that. And so that's all internal to the computer. And what we want to do is we have downloaded it was lab0-0, right? So there is the notebook that I just downloaded from the class server, lab0-0. And obviously, in a second, I will double click on that. So we double click on lab0-0 and nothing happens. We do it again. And now it looks an awful lot like what we saw on the server, except that now those are perfectly functional web pages. So in place of your name here, somebody pick a name. I'll choose your name. Jeremiah. Jeremia. H. And sure enough, we've changed it to script. So that would be the best way for you to get the structure of the laboratory and the exercises. Download on your machine. Literally just run the first cell or put a bogus cell in, make sure it runs, and then you have it. I would suggest on your computers to go ahead and just create a directory to keep all of your Python notebooks in for this class. Call it something like engr-1330 Python notebooks or whatever you like, something that you can remember, and then always just download to that, and that keeps you from cluttering up the rest of your file system. However, you can do what you want. That's the beauty of the freedom of choice. But if you keep it in one place, you will find it easier to find stuff when things get desperate, which they will 5 minutes before they're due. Books, links, that's pretty good. I managed to use up almost all the time. I got 10 minutes to try to go through computational thinking. So let me return to so does that make sense? You think you all remember how to do that? You probably won't, but you get another chance to try it in lab. The whole laboratory in 10 minutes will be to illustrate the whole install process. It takes 10 or 15 minutes, it takes some time. So the install is not click, wait a few seconds, it's found all your credit card numbers and it's happy. It's got to download packages and install them onto your file system. And it's a couple of big gigabytes. It's a pretty big package. So depending on the speed of the network that you are when you're hooked up, it can take 10 minutes to an hour. I would suggest do it on campus. If you have access to wired internet, this kind of stuff with the cables, that's usually faster. Do that, but it'll work over the wireless. Okay. And then once it's installed, you'll have that Anaconda Navigator like I just showed you. And it will look the same whether it's Windows or Macintosh. If you happen to be a Java person or a Chromebook, you're kind of on your own, not Java, Linux or Chromebook, you're kind of on your own. But if you're already using Linux in your university laptop, you don't need us. You'll be able to figure it out. To do this on a Linux install, just go to your update package, apt-get, update, Jupyter. Just read the instructions on the Jupyter book site. And it too takes about a half a day to get it configured correctly. Okay. So we do have enough time to talk about computational thinking concepts. So the title, in the title of the course is Computational Thinking with Data Science. Ironically, computational thinking and data science, while they both involve computer and 0 and +5 volts, barest form of them, they're not necessarily compatible things that should be together, but that was an argument that was lost. Computational thinking is a jargon name that's given to the thought processes I'm reading now, involved in expressing solutions as computational steps or algorithms that can be carried out by a computer. Data science happens to be one valuable application of computational thinking. Just to share with you all, the two never should have been in the same class. But we'll go through the computational thinking part. So when I went to school, that was back when pterodactyls flew freely in the skies, dinosaurs roamed the earth. I think we didn't even call it computational thinking. It was just problem-solving protocols. But other than the jargon changing, the ideas haven't changed for hundreds of years. And the actual name comes from a paper by, I can't remember her first name, Dr. Wing, and I think she was University of Pittsburgh at the time. We'll go take a look at that. Carnegie Mellon is where she was working. So Carnegie Mellon is a big deal in computing. And at some point, a letter to the editor kind of paper was written. And that's not a peer-reviewed journal publication. It's just a letter to the editor. Hey, this is my idea. And the world glommed onto this. And said, oh, computational thinking to make everything better. Everybody be able to write code, and before you know it, the world will be a better place. So I would suggest that you read this on your own, so you at least have background of where the term computational thinking comes from. She explicitly says somewhere in that thing, none of this is new. We've been doing this all along, but I've just invented a really cool new name for it, and I'm going to be famous for it. I'm going to inflict my pain and suffering on hundreds and hundreds of people over the next 20 years. And you are part of those hundreds of hundreds. The key aspects of this paper are not the actual coding aspects, not necessarily how to build a specific algorithm, but the idea of organized algorithmic thought. And that is valuable. So that is worth retaining. So there is the source of computational thinking, the jargon. And there are 5 identifiable fundamental principles of taking a problem using computational thinking aspects to get to the solution. Not every problem in the world can be solved this way, but those that can, this is a fairly efficient strategy to get it done. First aspect that's easily identified is decomposition. So General Sherman in his march to the sea during the US Civil War in the 1860s, he had a form of decomposition. What was it called?
American. I may have my wrong general. It's called divide and conquer. Split stuff up into small pieces and just wipe out each pieces. Later on, General Powell, in a much more recent war, had a variant of decomposition called shock and awe, which was a form of divide and conquer. You break things into small pieces and then you obliterate them. Pretty soon there's nothing left to worry about. So we have just recognized a pattern 200 years apart in warfare. Probably a really bad example. That's come up with. Pattern recognition is the second identifiable thing. We do it every day in our lives. If we don't, drove here today, the fact you got here, it's a miracle. Following the same patterns that you've recognized through your whole automotive driving career, unless you're like me and you drive in your sleep. That's where you recognize a repeating pattern and you can leverage that. So we got this pattern. Here's how we solved it last time. We just keep doing it again, but we change the inputs. Same problem, different inputs. The next is abstraction, which is to take the real case and abstract just the important features of it and solve that. So that's the essence of modeling the world. So we use models of reality to help us make decisions. Algorithms is what you would normally expect in a computer class. This is how we instruct the computer to take a linear system of equations represented as matrices and vectors and come up with a unique solution to that. The last part is one I've added called system integration. All that stuff is cool. Those are really cool names. But if you can't integrate it into something that is usable, what's the point? The point is there is no point. If you can't integrate it, it doesn't matter. So system integration would be the implementation aspect. In the case of this book, it's integrated as a book and it's now being displayed to you on the screen. So going through these one at a time in the next 2 minutes. Decomposition is taking a complex problem and breaking it down into a series of simple problems. You do that every day in this class and other classes anyway. So there's nothing new there for you. There's a few examples listed here. At the end of decomposition, we often have a framework of sub-problems. Josh, your TA, calls them, I think, a scaffold. He's got terminology for that. And we use the scaffolding of the framework to guide the rest of our solution process. Kind of literally the obvious. You solve one at a time, and when you get to the end, you put it all together with some kind of glue, and you have addressed your computational problem. Pattern recognition refers to finding things that repeat or are similar. And pattern recognition is valuable because that's what allows us to leverage automation. The whole value of our computers is they can do stuff over and over again. As long as we keep feeding them electricity, they are happy. It's not like the movies where they're out to end us all. They may do that by sheer stupidity on our part, but their mission in life is to burn electricity and stay warm. And then abstraction is, again, determining important characteristics of a problem. And finally, we get to algorithms, and I will leave off and get you all ready for lab with this cartoon taken from New Yorker magazine. It's not really an algorithm, but I always thought this: do I stand dead or go to the bathroom? It's a formula without it. I dare say everybody in this room has experienced some version of this. You don't have to show a hand and say, if you're there and it's almost time to wake up, warm it up, stick your nose out when it's cold out there. You gotta pee. So you have to implement the pee approach. Bladder pressure times the ratio of the time required to fall back to sleep after you get up. So divided by the wake up time. So that's actually a distance between the moment side run this algorithm and when you have to be out there anyway, divided by your laziness factor. Now you see if your laziness factor is huge,
the p-value gets pretty small, and your classifier will keep you in bed almost to where you wet your bed. That's an example, humorous by intent, of an algorithm. You would execute that and decide whether you get out of bed or not. All right, so I'm about to cut you loose to go find a place to attend the lab. I want to point out one thing. You're stealing stuff in this class from other places. Be sure to cite the source. One elaborate way of citing the source in the area, much better in classes, and get another class. I'll initially be quite happy to get the URL. Put it in the source. So I call that CCMR. Copy, cite, modify, reuse. That is the acronym for anything you take from someone else, attribute it. Okay, I will end my part of the class now. At 9 o'clock, actually, I have to get all you. You should be getting an email in the next 10 minutes that will give you the link to access the lab. And thank you for your attention. Have a great day. Welcome back to the 2022 spring semester at Texas Tech University. May all of you stay well. Hey, Josh, you still there?
Yep.
Okay, I'm going to disconnect, and hopefully it will maintain the connection. If not, I'll reconnect and I'll send you the link. Okay.
Okie doke. Sounds good.
Yes, sir.
So on Friday, are you good? You're not going to be here?
I will not be here this Friday.
So it's just the lab online on Friday?
Yeah, we will get a link set up and email you the credentials.
Thank you.
Was there an email before this?
There was not.
Okay, it's okay.
Sir, I'm in the waiting list in this class,
Okay.
and well, it says in my schedule builder that I'm in class, but I don't have access to Blackboard. I don't know what's
Okay.
going on.
Well, let me write your name down.
Thank you.
I can't personally do anything about that just yet, but I can just. Okay, so.
Samuel Fernandez.
And which department are you in?
Industrial engineering.
You have to call over to your advisor.
Thank you.
She or he.
For the link right now, can I like miss or for the no credit class?
What's your email?
Yeah, it's SAMUEF. Instead of the LF. ER at TTU.edu. Yeah.
Okay, I will add you to the email that I will be sending everybody as soon as I can figure out how to do it.
Thank you, sir.
So change the interface.
Bye.
Bye-bye.
I was just wondering, do we need to buy like the textbook or anything that's on the syllabus? Or...
The textbook that's mentioned on the syllabus for this class is online. It's free.
Okay, sweet. And then lab
Hello.
Hello, okay, that worked. Let me get all the emails and I will send it to the students.
Okie doke. I almost, well, not almost. I thought about putting a email out through the course tools, but I figured it's probably best if you do it since it's a personal room.
Yeah, oh, I don't, actually, I don't even have an email list yet, but I'm gonna go ahead and get it off of the Blackboard now.
Yeah, yeah. At least I hope
Wow.
that one works.
New window. Blackboard. Oh, no, that was not what I want. I want banner. The web people changed all the interfaces. I can't find shit.
You looking for the email on Blackboard?
I'm looking for actually the course listing. That's it's
Oh,
in Portal. That's it.
yeah, I hate that.
Portal TTU. Hopefully single sign-on works. No, it doesn't. I don't get it. I mean, it's 2,500 people are all trying to log into it right now. I don't get why it doesn't work. Just don't. Okay, I want to go as faculty. And get my detailed schedule for the class. Get class list. Okay, cool. We're almost there. Display the email list. Grab all that and I will send, hit the copy. Hopefully this is the right section. Yeah, section 1. And then I want to, guess I want to forward this message. Okay, so you're gonna get, I'm gonna forward the message and you'll be in the forwarding list. You can ignore it. Once I figure out how to forward the message. Paste. Okay, very cool. I'm gonna see if I can actually reclaim host. Or at least co-host.
Okay, let me know if it doesn't work and I'll
Yeah,
try to do it.
I can't because I actually transferred ownership of the meeting to you, but if you let me be host again, I'll make us co-host and I'll introduce you and then
There you go.
I'll stay out of the way. Okay, very cool. Multiple participants. Okay, so we
Should be able to see my screen now.
yeah, I see your screen and I should be able to share mine back to you.
Yeah, just kick me off whenever you want. And I'll,
So you see my screen now?
negative. I see my screen and I see, so the Zoom thingy is just the little icons. So it's showing my camera and then your non-camera. So if I do stop,
And if you stop share,
it
and then-
goes full screen.
and then I can
And-
share and then you
Yep.
get, okay, cool. Now we know how to do it. Let me go ahead and let all these students in.
Ah, yes, we need those.
Wow, that's really good turnout, actually. Half of the people already.
Goodness.
So Josh, there's 49 enrolled. Oh, let's see, there's one I have to add. Let me go ahead and get that taken care of. It's on the right.
Let's see. All my jokes are lame math jokes, and you'll get plenty of them throughout the semester, but I can't think of a good one for the first lab.
There, I should take care of that, and I will. So welcome to the 37 some odd people that are joining Engineering 1330 Lab 0 for Section 1, 38 people. I've muted you all intentionally, and it looks like most of you have your video turned off. That's up to you whether you want to run your video or not, at least in this particular lab. It has some benefits in preserving bandwidth. On the screen for the Zoom call right now, the person you see is it me or is it you, Josh?
You have the no one's sharing the screen right now. You can see my camera and your camera's off. I can share.
Okay, leave your camera on as long as you're talking. So the TA for the class is named Josh Archer. He'll be introducing himself in a second. And the usual format for the labs is, with the exception of this Friday, I'll start the lab off, introduce him, and just let him take over. So he will be your instructor for the next 50 minutes. His guidance is he'll go through whatever the numbered lab is, and usually the last few minutes of the time he asks for questions. And if there are none, he will go ahead and show you what the homework assignment is. Not how to do it, but just so that you know where it is. So Josh, you may take over.
Okie doke. So this is going to be the first lab. And what I'm going to do, probably at least the first 2 times, is go through the entire process of getting a lab open. So interesting. So I keep the chat open of Zoom the entire time. That's generally where I prefer questions be asked. And if I, haven't seen it, then feel free to speak up on voice. It's just I get distracted when people start talking. Apparently, the students have the ability to screen share as well. Don't know if that's true or not, but that's what the message I got. All right, so let's start from the very beginning. So right here, I have Anaconda up. And what I'm going to do is, and if you don't have this installed, don't worry about it. We're going to go through it. That's pretty much the lab. I'm going to go to Jupyter Lab here. I'm going to hit the launch button. All right, so it opens up the local host for my Jupyter Lab. So it's the first window. That's almost always going to, I'm pretty sure it's always going to be open because this is the lab. And the other one I'm going to do is open up the syllabus. And from the syllabus, you can get to every lab that we're going to be doing. You can control F if you want, however you want to get to it. So I'm going to share some, little keyboard shortcuts. You can either middle click on your mouse, or you can hold Control and click to open these two in the new window. Most labs are going to consist of a lab and homework, just like this one here is lab 0 and exercise set 0. All right, cool. So what do we got here? We have an HTML page. That's neat, but that's not actually what we're going to be working with. I just opened them like this because this is the easiest way to show how to actually get the Jupyter Lab. So what I'm going to do is I'm going to right click this link right here. I'm going to save the link. It's already saved on my computer, but that's what you guys need to do. Right click, save as. And then what I'm going to do is I've gone to the place that I have it downloaded. And I'm going to drag and drop. And drag and drop. All right, now that that's done, double click it. And there we are. All right, now that that is out of the way, I'm going to shift my window share to just this. So Jupyter Lab runs in Edge for me. I use Edge for Jupyter Lab strictly because I don't use it for anything else. So everything here is just stuff for lab. The first thing I'm going to share with you is probably the most useful thing I can teach you, at least in the first couple of weeks. Go to settings, theme, dark. That will save you some retina cells. Now, some formula look kind of funky when you shift to dark mode, but I know this is, what was the terms I used? I'll have to think about it. I'm from the computer science department. My job, other than teaching, is code. I code all the time. That's what I do. This is an engineering class, so you could be from any department in engineering. You may not code as much as I do. You might, who knows? But I'm just giving you a tip. If you're ever going to be coding for more than like an hour or so, dark mode, very nice. All right. So we're going to do the same thing with the take home. I'm just going to get that out of the way. I'm going to save it. And these things should be saving as a .ipynb file. That's the file extension. I'm going to drag that in here also. All right. So we have the lab and essentially what is your homework. Now during the lab, what we're going to do is I'm going to essentially walk through the entire thing, do the things that are empty, take questions, and go from there. I highly encourage the students to ask questions in the chat usually, but it's fine if you do it via voice if I'm not responding, because I learned a long time ago, and this can be different for different people, but at least for myself and in my experience, the other students I knew, and once I started teaching, the ones I would teach, is in courses like this, notes don't do you much good. And what I mean by that is, if you are sitting there right now, which wouldn't make much sense because it's getting recorded, but if you're sitting there and I'm going through this and you're taking notes and blah, 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 instead of paying attention to what I'm doing, engaging whether you understand it or not, you're gonna be in trouble, because the time we have here together is time for you to go, hey, wait a minute, that one part doesn't make much sense. And because the next 3 parts build off of what we're talking about right now, I'm going to be totally lost if I don't stop the progression of what we're talking about and really dig into it. So I highly encourage, when you are, listening to, here's what I want you to do. I want you to listen to me, follow along with what I'm doing, and if you don't understand something, say what you don't understand in the chat, and I'll look at it and we'll work at it there, because it doesn't do me any good for you guys to be completely lost. If we're on lab 2 and you don't get it, and then on lab 6, you're still stuck on trying to figure out lab 2, and then you come and my office hours like, yeah, I'm not really sure how to do this. This is 4 weeks ago. What were you doing? So don't be shy. Feel free to ask questions, and highly encourage that. So what are we going to do for lab 0? Well, pretty much we're going to get all the framework up and running. So the things I've put here, getting the Jupyter Lab open, running, Anaconda installed, that's pretty much what we're going to be doing. So, well, what I just did there is kind of an interesting introduction into what we're actually looking at here. So, yeah, this is Edge, but as you see in this tab here, this is a Jupyter Lab tab, and we're looking at these weird file extensions here. What is this? It's an interactive Python notebook. That's cool, sort of. Well, what's an interactive Python notebook? What's it good for? There's a joke there somewhere about the war. So what is it good for? I don't know. Well, let's Python example. Just there we go. That'll work. I could have typed that myself, but oh well. All right, here is a text file. I open up my Python interpreter and tell it to interpret from this file. It's gonna run. It's gonna do what I want it to do. So why do I bother doing anything other than a text file? Text files are easy. They're small. They're simple. They don't get confusing at all. Well, the reason is they're simple. They're too simple sometimes. Depending on your level of what you want to do, you want some other nice stuff that'll help. And that's kind of what these notebooks are for. That's what I'm going to call them from now on, is a notebook. Notebooks consist of cells. So this is a cell. See the blue line here? This is a cell. This is another cell. And every cell is one of 3 types. We've got Markdown, Code, and Raw. The ones we're really going to focus on are Code and Markdown. What's Code cell? Well, that's where code goes. I think there's one in here. So this is a code cell. And what can I do with it? I can execute it right from here. I don't have to open up my interpreter. I don't have to do anything fancy. I just run it right from here. Code cell. Well, what's the Markdown cell? It's pretty much anything else. We'll talk about raw cells at some point probably, but all this nice images and font and horizontal lines and bulleted lists, that's what the Markdown cells are for. So think of a notebook as all the regular stuff we can have for our code cells with nice comments. That's what these Markdown cells really are. Instead of having to say in one big file, this is a comment and the line below is code. Instead of having to do stuff like that, well, I have a nice Markdown cell that looks better. So that's what these are for, the notebook files. So how do we even get here to be able to look at these? Well, we're going to be using something called Anaconda. It is a framework, and we're going to spend the lab getting it started. And in my experience, people, well, I guess the Wi-Fi might be kind of slow. Sometimes it takes a long time to download. So we're going to go to the page where we download it. We're going to go through the whole process. I already have it installed, obviously. So I'm only going to take you to as far as hitting the go button, and I'm not going to click it. So let's go to their webpage. I think in a notebook file, you can't do the middle click thing I was talking about, but if you just left click, it's fine. So it's anaconda.com. I think we can start from here. This is, if you just type it in, anaconda.com. What we're going to be using is the individual edition. You'll find that with software, almost universally, there's going to be a free edition, which in this case is the individual edition. And this is for, so Anaconda's in the business of, hey, we got a framework. And you're going to pay us to use the framework. Okay, well, why would I pay you to use the framework? Well, here's a free version. Up to 5 people can use it. You can use it for a month. You're like, wow, this is awesome. I want 1,000, my entire fleet of people to use it. Okay, cool. Now you're going to pay for it. Well, you're just one person. You're just a student. Generally, there is a student or an individual edition that's free. So that's what we're going to do. So you're going to download this. And I suppose I can download it again. It's not like it's going to hurt. Let's see. Don't remember having to do a whole bunch of nonsense like in getting an email, but just put in, I encourage, here's another tip. I encourage everybody to have a spam email. So like Hotmail or something where things that require you to enter an email and you don't want to get spammed forever, just put that one there. So put in your email and yeah, burn your email account. So get the download started. And then once it's finished, just run through the installer, do all the default stuff. And well, here's the installer. Nope, same thing. If you're not running Windows, well, I guess step one, if you are running 32-bit Windows, that's impressive at this point. You're gonna need to be doing 64-bit. If you're not running Windows, here's installers for the other things. If you're not using Mac or if you're not using Linux, not Linux, Unix, generally, the rule kind of goes, if your operating system isn't one of those standard 3, you accept the responsibility of knowing what to do if your specific OS doesn't do something that the standard ones do. If you are in that situation, you don't know, talk to me about it and I'll show you how to get a Windows virtual machine up and running pretty quick. I mean, it's as easy as, let's see, wine in virtual machine. There you go. Wine is a wine tasting. Wine is a Windows virtual machine that you can run on Unix. Works pretty well. Yeah, Chromebooks may have to do some finagling, but other than that, it should use it. The installer should work fine. So after that, you should get to, I'll share the whole thing again. Here's the Anaconda Navigator. Got a whole bunch of stuff. I remember at one point we had to do the prompt for installing a library, but if we have to do that, I'll guide you through it, so don't worry about it. This is the one you're going to be using most of the time, Jupyter Lab. I think as Dr. Cleveland mentioned, you could use Notebook, but the lab's the one I always use. So I'm going to go back to the actual lab. So here's where, after all that fun stuff of installing, we actually get to. You'll have the local host with, I've made some folders here, and then you just drag your files in here. You can drag text files. You can pretty much do whatever you want, but drag in the downloaded lab files. So that would be these two. So drag those in here, and there we are. Okie doke. So for some people, the installation takes a while. For others, it's probably already done. If you're having any issues with it, put a note in the chat, and I'll see what we can do. All right. So let's actually tinker with this file here a bit. So as I mentioned before, okay, yeah, this one here. There should be a PowerPoint of let that go. Yeah, this is a PowerPoint for Anaconda install. Right, so let's tinker with some stuff. Tinkering is very useful when you don't. Your tool, you're gonna mess with it, see what it can do. So what is this tool? this notebook file, this .ipynb. Huh. Interesting. Well, it's a list of cells. What is a cell? Well, it can either be a markdown or a code cell. Let's not worry about raw right now. So what does a markdown cell look like? Well, it looks like this. I double click the cell and now I can edit it. And I can do a whole bunch of stuff with it. As you can see here, there's two pound signs in front of the text here. And what that does is it changes the style of header. So I can make it larger or smaller. I can change the color. I can change the, I can make it italicized, all that fun stuff. So that's what a markdown cell is for. It's essentially, think of it as, here's my comments that have extra power. It's not just text. Cool. Well, that's all well and nice, but the real thing we want to be messing with are the code cells. Now, as you can see, there is some stuff here that is, this is what's called a comment. I can put whatever I want here, and it's not going to execute. What do I mean by execute? Well, I'll show you. 3 plus 2, sure, or 12, that's fine too. When I execute this, now the hotkey I'm using is shift enter. So shift enter, and the button for it's right here. So when I execute code or a code cell, what it's going to do is it's going to go sequentially. It's going to go sequentially through the lines here, and it's going to do this one, and then it's going to do this one, and it's going to do everything inside the cell that it sees, unless I put this symbol, print. This won't print, because that is a comment. This symbol right here makes everything on the line a comment. What are comments? It's text that doesn't run but helps us understand the code. That's what it is. That's what comments do. So what was actually here before? Well, it is the classic entry to every time you get a new language, every time you get a new tool. This is usually what you do. You do hello world. So you print hello world. It's been in textbooks since before I started doing this. So you run it and it prints out hello world. Now, what's something everyone can do is, well, you put your own name in here. So I'm going to say that's me. So it's going to print, and this is unique to me. So I encourage everyone to do that. Tinker around with it as you wish. Put whatever you want in here and execute it. Or if you want, you can hit this button right here. You can make another one. Print another cell. And I can make markdown cells. I can do whatever I want. Markdown. Let's see, I'll make this one bold. Bold text. Okay. There is a huge, there's a cheat sheet out there. I'll show it to you at the end of the lab of all the format stuff you can do with Markdown Cells. So you can make a different color, different fonts, all sorts of things. So that's the first thing. Code cells, execute, printing stuff. Cool. Well, let us move on to the next one. So let's identify the cell types below. Well, how do we do that? What do we want to do? Well, we've got a list of stuff. I don't know what those things are. And we need to identify them. Well, what are we identifying? Well, there's going to be cells. So there's going to be a collection of cells. And I need to, tell what kind of cell it is. That's the exercise. All right, so the question is, how do you activate and run the cell? It depends on what you mean by activate. I'm going to assume what you mean is you have code in the cell, or you've got some text in the cell and you want it to be, this is in the editor mode. You want it to not be in the editor mode. There's at least 2 ways to do it. I use the hotkey, which is Shift Enter, hold Shift, press Enter, or you can press this button right here. Run the selected cells in advance. Yep, new problem. All right, so in classic fashion, I suddenly forgot everything that I just said. I don't know what's going on or anything. So I'm going to rely on you guys to tell me what these cell types are. So I'm going off of my brain telling me that everything between these 2 sections is what I need to be identifying. So this one, and this one. So this one says, I am, what kind of cell am I? So what kind of cell is this? Can somebody tell me? I seem to recall there were 3 types, but that's about all I can remember. So what kind of cell is the one I have highlighted? A code cell. Okay. Seems reasonable. What makes you say code cell? Yes, it does say at the top. It says right here. This is a very good, it's probably the easiest way to figure out what kind of cell you're looking at. So this is a code cell. Cool. What happens if I execute it? Nothing. It's full of comments. But I can change that if I want. Print, this is a code cell. All right. All right. So this one, what kind of cell is this? It is a code cell. Very good. The instructions in the code cell say to change it to a Markdown cell and then run it. Well, let's do things one at a time. How do I change this to a Markdown cell? The menu at the top. Yep, you can change things just like that. So I changed to a Markdown cell and the exact same hotkey or the exact same button. Oh, there you go. There's a hotkey right there. I press Escape plus M, and that'll change it to Markdown. So the hotkey I use to execute is Shift Enter, and now we have the Markdown cell as ran, and now it is in, we'll call it view mode as opposed to edit mode. If I have time, I'll change the color or something. All right, now here's what we were talking about sort of earlier. There's 3 kinds of cells. We've looked at a code cell, we've looked at a Markdown cell. Now what is this? It's kind of weird. The Markdown cells have like blue text and stuff, and the code cells, we have syntax highlighting, but what the heck is this? It is a raw cell. Print. This is a raw cell. It doesn't have any color. Why? What is it? What happens when I execute it? Nothing. That's weird. What on earth would I use this for? Well, raw cells are generally the least used. The best use for them that I've seen is, let's say you have some code that you are going to eventually want to run, but you don't want it to be ran right now. So like imagine delete system 32. Let's say I've got a function that deletes a very crucial folder on your computer. This will brick your machine. For some reason I have it in the lab, but I don't want you to ever run it, at least not yet. I'm gonna make it a raw cell. So this is probably code that I don't want you to run yet. And then when you do want to run it, you change it to code. And don't worry, this doesn't actually do anything. It's just trying to think of a dramatic example. It's just a function name. We'll get into what a function is in a different lab. I can name this as function name 61. Who knows? It's not defined, so it'll give me an error. All right, so that's a raw cell. What does it do? It does nothing. It intentionally does nothing. It's just text. So those are the 3 kinds. We got code, we got Markdown, and raw. You can think of them as code, fancy comments, regular comments. or whatever works best for you. All right. So let us quickly talk about, yeah, okay, we can do that. I'm gonna, instead of raw, I'm gonna change this to code. And as Dr. Cleveland said, the pink box of encouragement. So what do I got here? Well, this is my error message. It both traces down the bajillion lines of code to where we are. That's what the arrow is for. And it gives me the error message that is associated with this problem. Well, what's the problem? Well, let's go through it. I've got a line of comments. Nothing wrong with that. And then what I did here is I called a function. Well, the problem is I didn't define this function. And so when I call a function that's not defined, the here's what the interpreter does. It says, okay, you want to use function 61. Got it. I'm going to go look for function 61. There is no function 61. Hey, there's no function 61. That's what this error message is. You'll find a whole bunch of error messages. Congratulations. That's what you're going to be doing for the rest of your life if you're in engineering. So I suggest you become acquainted with how to deal with them. Now, would I deal with this one? Well, I would either change this to something else or define my function. So let's see, we'll do this as print. I made a function, hooray. Cool. All right. So as I said at the start, yeah, that is worth mentioning. This isn't unique to programming or engineering. It is, I would say, unique to science, is that the more you know, the more experience you have, the more you know how little you know. So when I have an error, invalid syntax, oh, well, what's that going to do? Who knows? It doesn't mean I'm stupid. If you had a counter going every time you had an error message, mine would be in the tens of thousands by now. It's just really what this message is. And I've actually done this before. Like I've written a compiler that, so what happens when I hit Shift Enter? There's this thing called an interpreter. And what it does is it scans all my text here and says, okay, this person wants some text to actually be code and run something. I've written these before. And what happens is the person who wrote the interpreter came in here and was like, all right, well, that's not a very good one. Let's do this one. The person who wrote it recognized that when the interpreter gets to the point towards like, hey, I can't find your function, they wrote this by hand. So name, whatever it is not defined. So it's just, think of this as someone from, I don't know, 20 years ago, reaching through time to try to help you out. Let's see. Question is, how did you change me to a Markdown cell and run it again into a title again? So the Markdown cells have what I'll call an edit mode and a view mode. Right now it's in view mode. If you double click it, which I will constantly do because I fidget with the mouse, I do it accidentally. Everything here, these are all Markdown cells. To change it back, you execute it. So you either hit the button here or you do the Shift Enter hotkey. So Shift Enter will run it. Okay. So let's see here. Let me get Blackboard up. And I will change my screen to the whole screen. All right. Now, the way homework is going to be submitted. So what Dr. Cleveland just mentioned is it's probably not a coincidence. It was made this way on purpose. Is that if this is a code cell, the pound sign here makes it a comment, makes the text here a comment. Everything on the line. If I go to a next line, it won't be a comment anymore. But the comment in a code cell and the same symbol in a markdown cell, they don't having it there doesn't mess it up either way. Is the best way to say it. All right, back to this one. So what we'll want submitted, and this is for your homework. Both the lab, we're going to go through it. Like, here's how things are generally going to go. I'm going to go through the lab and I'm going to do most of the stuff. I'm going to ask you guys some questions, and I highly, highly encourage that you follow along and do the same thing. Not only is it better for you to understand, but this actually is part of your grade. It's not as much of, it's less points than the actual homework itself, but you're going to go in here and you're going to replace all the stuff in here that's specific to you, and you're going to submit it. Yes, I will do the conversion in a moment. So that's the lab. We essentially do it together, and you do submit it, and there are points for it, so don't forget it. And there is the homework, and this is the same process, except I'm not going to do the whole thing with you. Sometimes I'll do some of it. Sometimes I won't do. Generally, it will not be the case that I do nothing. The least I will do is at least look at it and give some comments. And then you do it, and then you submit it. Now, what do you submit? Well, notice, I'm assuming we're wanting PDF, not HTML. Is that correct? Okay, yes. This is just a typo. The reason I don't have an example up right now, maybe one day I'll show you, but what we want is the notebook file. There you go. Blackboard will reject HTML. Also, it's a whole bunch of text that I don't want to have to convert. I want the notebook file and a PDF of your notebook file. Now, what's that about? What is that? Why do I need to do that? Because that's what lets me view it and grade it. Now, how on earth am I going to get a PDF out of this? Well, there's two ways. One is the more steps, but generally works better. I'm going to save this as, let's see, where's save? Oh yeah, it's under file. File, save notebook as, and file. What am I looking? Oh, sorry, I want export. Now here's the short one. Click the PDF button. The Anaconda framework has a converter that will convert this to PDF, and PDF is what I want. However, sometimes it doesn't work, and for some students it just never works. But what almost always works is we're going to convert it to an HTML. I'm assuming everyone can see my little pop-up here. And what I'm going to do now, I'm going to open that up in my folder, and I'm going to go to HTML to PDF. This is the actual website. You could just Google it, HTML to PDF conversion. And as with everything you Google, be careful what you Google. If you see a giant green button says go, install me, generally don't click those. But HTML, the number 2, PDF, this will do it. And in this case, I think the green button is actually what makes it work. So I dragged my lab in there. And let's see, I believe, try that one. All right, so it gave me a file or a zip file. It automatically runs. All right, so I have a zip file, and let's see, I think what I have is as a PDF now, and I guess I'll just share my entire screen so you can see it. You share entire screen. Oh, I do have my entire screen. So there you go. Yeah, there it is. There's the PDF right there. So the output of this web page, will be a zip file containing the PDF. Please do not submit the zip file. Please submit. The question is, can we print? What's the function of raw again? It depends on what you mean by print. I will answer that in a moment. The other way to get the PDF is to file, export as PDF. And let's see if it works. Big bucks, no whammies. Yep. See, sometimes it doesn't work. It's finicky.
You got the NB convert because you don't have a functioning LaTeX subsystem.
Which is weird because I didn't change anything.
It's a computer.
That's true. All right. So I'm required to end. So lab time's over. It's 9:50. I generally stick around to take questions and answer what I can, but it is 9:50. Sometimes I'll end the recording here. Sometimes not.
So let's get
So-
James' question.
Right.
Can we print?
It depends on what you mean by print. If you're talking about the actual print function, go nuts. I highly encourage using the print function all over the place to see what you're doing. Can you print the page physically as a piece of paper? Is that what you're asking?
The page for submission.
Are you talking about hopefully you can see like the as a PDF? I haven't tried it this way myself, but you know,
That kind of looks like it'll work on your computer. So
yeah. Test PDF. Let's see what it looks like. It looks okay to me. The purpose of the PDF is so that I can, there's 100 of you. It's so that I can quickly read. The PDF is a snapshot in time of your code. I can't run it, but I can see that you ran it. So that's why the PDF is there. And the reason I need the notebook file, I need them both, is so that I can run yours if I actually need to. So it looks like the print worked. If I get a PDF that, at least for the first few labs, I can't quite read, I will leave you a note. If you give me a zip file, I'll leave you a note and I'll take like a point off. But the further along we get, like towards the end of the lab, if you give me a zip file instead of a PDF, it's going to be like half off. I'm not going to grade it. I think that's all I can think of. So any questions?
okay, there's let's see. Parth, you submit the PDF and the Python notebook for the homework, because if the PDF is unreadable, we can at least look at the notebook.
Right.
And just because you can read it on your computer doesn't mean we can see it on Blackboard, because Blackboard has a phenomenal capability of breaking stuff.
It exists to,
Jake-
sorry, go ahead.
Jacob's question is, explain the Anaconda install again.
Sure.
On Blackboard, there's a video, and also if the install help, if you right click and download it and then open that as a PowerPoint, that should allow you to see an example, not fully worked, but it's the pieces that you need.
Let's see. What I will do is I'll go here.
It's supposed to be a PowerPoint. There you go. Okay, so this has Anaconda set up, and it's admittedly just 11 slides, but that should get you pretty far along the way. So it shows the individual edition, what installer to use. It does take a while. You're looking about an hour, depending on your internet speed. And then it just, I would suggest just accept the defaults. And when it gets done, you get this thing, and let's see, you see, if it has the keyword launch, like it is showing here, that means it installed and that application is ready to go. There's also, it'll have a button that says install. You click on that and it does further installation of whatever that subsystem is.
Right. So Anaconda, like if anybody's doing what's it called, scientific computing, you're going to be using R. So yeah, it's a framework. Eventually, probably at some point at the end of the class, you'll understand what a framework is.
Okay, Scott Boyer, yeah, if you have it already installed made, you're fine. Just create a
Yep.
separate directory to store all the stuff for this class in, so you don't bugger it up.
Yeah, you see my file system.
The question about the recording, I can't answer that. I don't know if it'll be available because I don't know if we'll be able to pull it off the Zoom server. Because I've never done that. This is an experiment, Adriana, where I started in class, I disconnected, and we kept the call running. We'll see what happens. But in general, probably classes won't be recorded, but labs will.
Right. I don't know if it's in the syllabus this semester, but generally kind of the policy is I'm going to do the best I can to make sure the recordings or the lab are there. But sometimes it fails. And there's all kinds of points of failure, and I can't always fix it. So if there is the case that there is a lab that the recording isn't there for, sorry, but I guess show up to my office hours. And
Colin, yes, your lab is over. You can leave whenever you
Yeah.
want. We're probably going to shut it down in a couple of minutes anyway.
Yeah. At 9:50, I mean, there's a good Simpsons joke where there's a sign that says "Do not enter," or "Do." I'm just a sign. You can leave whenever you want. It's probably not in your best interest, but at 9:50, I won't talk about anything crucial because that's when people have to go.
Okay, well, that was a good first lab. For the 12 of you that are remaining, feel free to disconnect because we're about to shut everything down.
The installer is a big file.
Pardon?
The installer is a big file.
It's 4 gigs, I think. It's huge.
Yeah, I've got 3 of them downloaded, so I'm gonna get rid of those.
Okay, that was good. I'll go ahead and shut down the meeting because I think I should be able to. And I'll see whatever happens on the recording. So I recorded it to my Zoom account, so it's supposed to be saved out in the cloud. We'll see what happens.
Okay, I'll see for the
And then
session later today.
right, and then Friday, I'll contact you Thursday sometime. We'll figure out how to make Friday work for everybody.
Sounds good.
Okay, have a good
you.
day, Josh.
You too.
Bye-bye. Shut this sucker down.